Hello and welcome to Solutions Live. My name is Ian McNeil. I'm a member of the Stiles University team and I'll be assisting with the session. We're happy to have you joining us for Automated Guided Vehicle Systems. You are currently analyzing your production flow and considering the incorporation of new automation. This webinar is just for you. We know how important keeping your production up and running is to your success. Today's session is one of the many creative ways Stiles is keeping our commitment to being the highest level of service, support, and responsiveness that you've come to expect from us. Stiles University is proudly celebrating 30 years as the industry's only nationally accredited training program. Our learning events provide comprehensive hands-on technical and applications training designed to equip manufacturers with the skills and knowledge needed to thrive. We are happy to be joined today by Eike Hein. Eike is a consultant with Schuler Consulting, and Stiles is proud to partner with Schuler to provide you with a full slate of resources to revolutionize your production. Schuler's many smart optimization tools include automated guided vehicles, which Eike will explore with us today. Solutions Live is going international for the first time, as Eike, who is based in Germany, is connecting with us while on assignment in Sweden. Just a note for our attendees, we will not be utilizing the raised hand feature during this presentation. If you require technical assistance, you can communicate with me and our administration team via the chat window. If you have questions, Eike, during this session, please submit them using the Q&A window at the bottom of your screen. We'll be sure to address all questions at the conclusion of the session. At this point, I want to welcome Eike to Solutions Live. Hello, Eike.
Hello. Hello from my side as well.
Hello.
Yeah, thank you for the introduction, Ryan. I hope you can see my screen from now on.
Yes, looks like we've got you, and we are all set to go. So without further ado, take it away.
Perfect, thank you. All right, so yeah, maybe first brief words about Schuler. So Schuler Consulting, it's also a part of the HOMAG group. Like Stiles, and yeah, we are operating worldwide. We're a consulting company mainly focused on production planning in the furniture industry, but we also do some projects in the information flow for the production. And yeah, we do that on the one hand for greenfield projects as well for brownfields. And yeah, that also in the US closely together with Stiles. And yeah, our team in the US counts 3 people, led by Florian Hauswirth, who is participating today as well. And yeah, then perhaps a few words about myself. I started while my study times at Schuler as an intern, and yeah, becoming afterwards a consultant, that since 2 years now. And yeah, I worked in several projects in chair manufacturing, interior door production, kitchen industry as well a lot. And while those projects, I was often involved in the topic of AGVs. And that's why I like to share my knowledge about that with you today. So let's start. First, I will give you some overview over the basics regarding AGVs. Afterwards, we will talk about vehicles, the system itself, and yeah, how to proceed while planning, what might be application possibilities, and afterwards there will be a short summary about that. So yeah, automated guided vehicles, that's, as most of you know, that's an internal floor-bounded transport system. And the primary task is material transport. I mentioned that because there are also kind of like vehicles for personal transport, but the AGVs are mostly for the material flow. Yeah, and inside the word AGV, this automated, I would like to go a little bit more deeper in, because there's also this autonomous thing, and that's most often used synonym, but there are slightly differences. So when we are talking about automated guided vehicle, we are speaking about vehicles which are not that smart. They have a certain smartness inside, of course, but they getting the information where to go and how should I proceed with the routes and which route do I need to take. That this informations are coming from a control system, a centralized one, and so you can say automated version is more like a master and slave system, so to say. When we are talking about autonomous vehicles, that's more when we are talking about cars outside on the street, where the developing is going on. And there, the vehicle itself is much smarter. There are high performance computers inside, and they are yeah, more thinking on their own. It's more a decentralized system then, and that's the main difference. So that's important to keep in mind, that when we are talking about automated guided vehicles, we yeah, it's more like the information must be given. All right, so first, the history of the AGVs. The most of you, I expect, don't know that it's even in the 1950s, there are the first AGVs were involved, but that it was really rudimentary vehicles with kind of motor and the kind of sensor for following a clear line, so to say. And 20 years later, 1970s, when the microcontrollers came up, they of course were added as well to the vehicles, and yeah, then the vehicles were more useful, so to say, and also a big advantage was then the automatic load transfer. So then the goods could be transferred automatically on the AGV or off. And yeah, 20 years later again, the Wi-Fi control was enabled, and also the sensor technology were much better developed. So they are now more accurate, more precise in navigation. Again, 20 years later, in 2010, the Internet of Things, or the industrial Internet of Things, is now will be able to connect the vehicles to those internet. And yeah, that is kind of, if you're talking about smart factories, that's a crucial point to base on. As well as the battery technology were involved much better. So now most of the suppliers using lithium batteries to reaching a higher capacity while being more light. And yeah, as we can see, more or less every 20 years roughly, it came the next big step. And so I expect for the next 5 to 10 years the next big step, and that is, from my point of view, definitely the autonomous driving, because there's so many developing in the car industry about that, and on a certain point there it will be swapped over, and the knowledge about that can be implemented in the AGVs as well. Also, we will have the object recognition, which is also coming more or less from the car industry. So we are then able to recognize, okay, there's a pallet in my way, so I need to go around that. So right now that's not possible. Yeah, okay. So then we will speak today about the different components. So on the vehicle side, we will have the different types of vehicles, also the motion types, how it can move and how not, how the energy supply could be fulfilled. On the system side, we need to talk about the location determination, the safeness, and as well the data. As I mentioned, it's quite important to supply them. So how to transmit the data, and according to that, the guidance control system. Yeah, and then yeah, some miscellaneous things like load transfer and load carriers, which are quite important as well. So now the following slides are more for afterwards. I put some very nice information sources in. yeah, it's really for afterwards, for if you want to go more deeper in detail and research something, you can look it up here. So yeah, so let's come to the different vehicle types. On the one hand, on the left side, you can see the most common one in our industry, I would say. That's the underwriting AGV. There we are working mostly with this kind of trays, this black tray you can see here, where the pallet is on. That allows us to yeah, put the pallet everywhere, and we don't need any forklifter. So that saves a lot of space while moving around with the goods. And yeah, it's most of those AGVs are able to lift load capacity up to 2.5 pounds, 2,500 pounds. Yeah, but yeah, it also depends on the special product and the different suppliers. In the middle, we can see the forklift AGV, and I think in the logistic industry, it's the most common one. So there it's more or less like a forklifter, but without a cabin for a person. And yeah, they are mostly able to lift up to 9,000 pounds load capacity. And on the right, we see a specialized AGV. It's an assembly AGV. It's, yeah, more or less like an underwriting AGV, but with a workbench on, so specific for the according product. And when we are seeing those, we can also have a short talk about the energy supply. So there are a bunch of different solutions for supplying the energy, but most common is the point related, what means that you can charge the vehicle only on a certain point. That might be, on the one hand, it's quite nice solution and inductive charging station, where the AGV is just driving on, and then it charges, and afterwards can directly go back. And the principle is mostly that you don't charge completely and then utilize the full capacity. It's more like recharging over the day. And that, yeah, shortens the charging times highly. On the other hand, we have also the direct connect possibility for charging. As you can see on the right picture, this green light, where the green light is, that is yeah, kind of charging station as well. So it makes sense for assembly. So the AGV is staying there for several minutes, so then we can charge while processing. Okay, so then the system, location determination. That is done almost every time by using the bearing technology as well as the dead reckoning technology. So, but in the bearing, I mean, the dead reckoning is more or less every time the same, but the bearing, it might differ, and therefore I would like to give you now some examples for that. In general, the accuracy about AGVs indoor is about ½ an inch, I would say, plus minus. It also depends a little bit on the sensoric technology and suppliers, but mostly it's about ½ an inch, plus minus. Yeah, so what we see here is bearing via landmarks. So on the left side, that is what you mostly know from your Google Maps or something. It's a GPS, more or less, where we have several satellites, and we have the engine, and then we get our position by measuring the distances. And the same principle we are using at the AGVs indoor, because the accuracy here is not high enough for production indoor. So here we're using these passive landmarks, and that's mostly reflectors on the wall or on the racks. and the rotating laser is recognizing them and measures then the distance and can interpolate the position. Yeah, then there are the bearing via guidelines and points. That's when we're talking about lines, that could be done either with a cable in the ground and using the induction technology. And then we have here the sensor for detecting it, or the same but different with an colored line. It's mostly a high contrast line, so we have a white one in the middle, and on the outside we have black lines. So this photo sensor can then detect clearly where the line lies. And then we have point related that works more with dead reckoning, because here it's only one point is recognized and the vehicle now knows where the next point should be from the system. And with dead reckoning, it goes to the next point, make a plausibility check, and then continues with the next point. But that is in a flowing process, not stopping every time, but it's in a flowing process. And it might be a kind of transponder in the ground, or also a QR code on the floor. That's also possible. All right. So then I would like to talk about the safeness. There we have two types we need to differ. So on the one hand, we have the safeness for the people, for the worker who are walking around the shop floor, and therefore nearly most of the suppliers working with this kind of laser detection, and the sensors can reach up to 25 feet, also depending a little bit on the sensor technology which is used, but in general we can say 25 feet. And that works as follows. If you have here our people from the top view, we separate this scanning range inside 4, or let's say 3 sections. If this worker is reaching the first, or the section 4, the AGV will lower the speed, and then the worker gets time to go out of the way. If not, or if he is not seeing the vehicle, he will reach zone 3, and there the AGV will again lower the speed. And that if that is not necessary enough, we have then the zone 2, and there the AGV will definitely stop. But in any case, if there's any problem with that, or the worker is moving too fast or anything, we have also this zone 1, which is a kind of bumper on the vehicle, and that is a kind of kill switch, that then the vehicle is definitely stopping, so there won't be any traumatic injuries or something. Yeah. So, and this is also, if we have, this is our AGV, and our load is bigger than this vehicle, then it might end up somewhere here. So the zones can be then customized. So according to the biggest load we will load on the vehicle, we can then adjust the zones. But of course, the maximum is 25 feet. On the other hand, we will have the cell safety, and that's because sometimes we are working also with quite heavy machines and robots together, and they are operating in a kind of cell. And inside the cell, there shouldn't be any operator. To avoid that, we have these fences around, but somehow we need to fetch the material out and bring new in, right? So therefore, there are several solutions. I will present here 2 of them. On the one hand, we have this sliding gate with the gates, with the fences. Here's this gray thing that is a kind of laser fence, which is then reckoning, okay, here's an AGV, the system, and tells the system. The system will then ask the AGV system, is it right? Is that an AGV? Is this not a worker or something? And then after the plausibility check, the AGV can enter. The gate will open and the AGV can enter the cell. On the other hand, we have also a quite nice solution where we don't use this metal fences, but complete laser gates, laser fences. So the standard situation would be that it's completely closed, and two lasers in addition are checking if there is anything which needs to enter the cell. And if the empty AGV is coming, it is a little bit lower than when it's fetching the material or transport the material. So then this dark blue laser will recognize, okay, that's an empty one. So I make free this shape for the AGV. So the AGV can enter, but no one else is able to enter the cell. So you have 100%, make sure to 100% that no one can enter the cell. And of course, on the other hand, when we got our load on, we will come back, and then the AGV is a little bit pushing up the load. So now it's a little bit kind of higher, and then the light blue one will recognize the height difference and say, okay, that is the AGV, and it has load on. So they will ask the system which kind of load is loaded on. And according to this information, it will give the more space free for, in this case, a car, to exactly let them out, but no one else can enter. So when we are now talking about the guidance control system and all the information, let's have a look. What is this data about? So mainly we are talking about transport orders. And what a transport order contains is mainly a transport source and a transport sink. So of course I need to know from where to where do I need to bring this kind of load. And for identifying this transport, I of course need also an ID number, and that's basically it for a very simple transport. But of course we can add additional elements. If I have a different priority on the transport, so perhaps this pallet is quite urgent and has to be moved, and the other one is not. So we can add priorities as well, and also good properties. So perhaps I'm using a system where I use different kinds of AGVs. So if one pallet is, let's say, three tons, so, and I have only an AGV which is able to transport 1 ton, I need to choose the other one, right? So with a higher load capacity to transport it. And yeah, also, of course, I can add multiple sources or things according to the routing of the goods. And yeah, then I need to trigger those transport orders, and that could be done in several ways. So on the one hand, of course, a sensor. So if a sensor like a laser recognize, okay, this pallet is full, it has reached a certain height, we can trigger to the transport order to get it away. On the other hand, we have this production data acquisition systems, what might be a terminal or a mobile device the worker has with them. So there we can on demand trigger manually the transport order. And of course, in addition, we have the fully connected and automated version via the manufacturing execution system, the MES system. where we are acting demand-oriented, time-oriented, depending on. So that's basically the three possibilities to trigger those. And yeah, how can we imagine how it really works? So on top, we have this typical pyramid, and on top we have the enterprise resource planning system or the MES system, or both. And there we create the transport order more or less, because there we have the knowledge about what do we produce, which kind of product, and which kind of routing through the production is necessary for that. So therefore we know, okay, we need to go from the saw 1 to the edge bender 2. And this information we will transfer to the guidance control system of the AGV. And that is the kind of a central system. Like you can compare it with Uber, for example. That's more or less like you as a person who want to have a transport, a Uber car, and so now you would be this blue part, and you're sending the information. I want to go from my location to a certain place, and this information you give to the Uber app, and the Uber app will then check the availability of the vehicles of the cars, and which is close by, and then is free, and then send it to you. And that is more or less exactly what the guidance control system is doing. And it is not only communicating to the vehicles, it's also to the transfer stations and the lifts and gates. So in this case, for example, the vehicle would be your Uber car. The transfer station is more or less you, because that is the point to go. So you get notification on your smartphone how minutes left until he arrives. And then, of course, because then lift gates would be traffic lights, but it's not realistic, because when we are talking about our own production facility, we can also, or we have to include also, if we have lifts, for example, and we need to use them, the guidance control system needs to talk to the lifts as well, or to the gates and fire doors and so on. So that's quite important. And yeah, I hope you got the better understanding of how it works. So then we will have a look on the planning side. So as I mentioned, the transport orders are a central point of the planning and of the topic as well. And therefore, we need to analyze how many transports we have and from where to where. So that is just a very simple example. I always would recommend to create those kind of material flow metrics or transport metrics, where we enter our sources and things. So every machine, more or less, or every point we want to go. And then, for example, we have from machine 1 to machine 2, we have 50 transports. And from machine 1 to machine 3, we have only 5 transports. And then we go back to the next source. From machine 2, we will have 40 transports to machine 3, and 15 transports are directly going to packaging to the end. And then we have from machine 3, of course, we have this 5 transports which are going back to machine 2, and 40 which are done after machine 3. So we get in total afterwards our 55, which we started with. Yeah, but that gives a really clearly overview about what we are talking about when we are talking about trying to automate the intralogistic. But perhaps for some people, or even for me, it's not clearly not nice visualized. So you can also work with this kind of Sankey charts. So that's quite helpful to realize really or visualize how the main material flow is yeah, processing while factoring. And here we can easily see it from one project. We have this main material flow, but from step to step there are more yeah, side flows as well, and some very slight ones. And that is also, if we would do that, this analysis correctly, we would perhaps forget about those transports from this saw to this rotor, because 2% and in an average day, I don't have it in mind. And afterwards, I will realize, oh, how do I transport parts from the saw to the rotor? So that's quite nice as well. Yeah, and okay, when we are now knowing from where to where do we transport, then the next question would be how. So of course with AGV in our example, but how, in which conditions are the parts? So on the one hand, we can, of course, talking about stacks, but even there's a question, what kind of stack? So yeah, so one of several opportunities inside the 1x1 stack, or we are talking about a 3x2, or could also be a 5x2, depending on the size of the parts. It's more in a bigger industry, or talking about chaotic stacks. So that's mostly common in the batch size 1 production. And yeah, why I'm talking about that is because we need to now not only the transporting, but also the stacking and feeding technology needs to interact with the AGV, right? So, and that is quite important, that we know exactly in which kind of condition is my stack, or do I use a stack? And according to that, I need to choose the right technology to feed the machines and to stack afterwards, and then transport by an AGV, for example, if chosen. On the other hand, because I mean, you can transport a lot of parts on a stack, right? But you can't get this part here out at first, because you don't have the single part access. And that you get when you use a kind of trolley. And that is also, you can implement it in a complete automatic process, like you can see on the left side. But also you can use it in a manual process. Also, it comes from an automatic destacking inside the trolley, but afterwards there's a manual process. So it's a kind of very nice thing, these trolleys. And you can reach every single part. So you can, it's more for the batch size 1 production, you can yeah, determine your sequence before and afterwards, and that's quite nice thing. And then you can make some kind of barcode or something on the slots, and then you can also scan the parts and identify the single parts, which you more or less not that nice can do in the stack. So that's quite nice. And how to transport those with an AGV? There are two options. So on the one hand, you can do it like a train. You see here this kind of connector. You can do it like that, but that utilizes quite a lot space while moving around and turning around and so on. It has to act like a train. But you can build your own trolleys by lifting it a little bit up, so that the underriding AGV can go under it, and then you can turn on the same position and yeah, move quite smart and so on. So that's would be my recommendation, to do it a little bit higher so the AGV can go under it. Okay, so when we are now knowing how to transport and what, we need to fetch the material from the machine cell, right? So therefore, we need to enter, or one possibility would be to enter this cell to get the material. So, and therefore, I already mentioned this laser fences or this guillotine fences. gates, we can do it like that. But the disadvantage on this side is, because I mean, that is an obvious thing how everyone would like to do it in the first place. But the disadvantage is AGVs are driving around 3 to 5 feet per second, but per minute, sorry. But the problem is when they enter the cell, they are very slow, and so that is one part where we also consider different solutions where we just enter a transfer station outside, and then we can go away with the AGV, and then the slow process to enter the material, let's enter the cell or go out, then that can be done afterwards by those transfer stations, but AGV can act more quickly. And as well, we have then different opportunities. Either we go from a roller conveyor with a chain conveyor to those trays I mentioned, or we have some kind of AGV with roller conveyors directly on, so we can then move from a roller conveyor directly on the AGV. Yeah, and then there's one thing, because I also mentioned a lot of data and how to manage it, and it needs to interact with an MES system, but not everyone has an MES system, right? So especially the smaller ones, but perhaps it might be useful for them as well to automate the interlogistic, so the good workers can stay on their places and continue working, and don't need to bring several stacks or trolleys to the next station, so they can continue working and be productive. And therefore, it might make sense to automate the intralogistic there as well. And that can be done by those train stations, let's say. So you have stations where the AGV brings a trolley, for example, and then there's a kind of traffic light which shows the operator, okay, here you can take that. And after processing the parts on a manual machine, like you can see on the bottom left, he can bring the trolley exact on this position. And that's important for the AGV because they don't have eyes like like us. So then it's exactly positioned, and the AGV can come and fetch it. And then therefore, of course, the operator needs to trigger it by a mobile device or something. And then the system knows, okay, I can fetch it and bring it to the next operation step. That's also quite nice. Now I would like to give some introduction about how it could look like in a layout point of view, and what is also important by laying it out. So on the one hand, if you have long distances with high traffic on, it also is important and recommended that we can that we have those parallel ways. So every way is in a one-way direction, and so no AGV, no vehicle is stopping in another one. It's always flowing, and or is able to flow, and that is quite important. And as well, we need to avoid dead ends. So we also need to try out build out loops, so the vehicles can always go on. And that's quite important. As well as charging stations should be distributed over the plant. So not a cumulative situation here where every charging station is in this corner, but on several places, like here's one and here's one, and outside this picture as well. And, okay, but if you don't have that much space, right, to build out these parallel ways, of course you can do also some kind of trick like a bypass. So then the one AGV can overtake another one, and so on. That's also of course possible. And then we're coming to dimension the path to go, so the aisle. And that is important also when we are talking about safety, that we let space on each side of the vehicle of about 20-inch. And that's because if the vehicle is coming and here is a wall, a worker couldn't go anywhere. So there needs to be space for those situations. And of course, that's not according to the size or dimension of the vehicle, but of the biggest transported good. So if you produce small parts, that's quite fine. But if you're producing, for example, doors or something really big, or your stack is quite big dimensioned, then you need to take those dimensions, the maximum size you would produce, that gives you the dimension of the width and length, of course. And when we are talking about turning stations or yeah, some kind of crossings where we turn around, we need, of course, to consider with diagonal and then add this 20 inches. So we get then our safety space around, of course. And that's also quite important, because mostly we are talking about more narrow productions, and then okay, there's enough space for one AGV, but yeah, in the end you end up with no safety space, and that's quite important. I don't know exactly how it is treated in the US, but in Germany you don't get it allowed to implement those without the safety space. Yeah, another example about the layout. Here we have the saw, edge bending, drilling, CNC processing, and afterwards assembly. And as you can see here as well, this long parallel lines for the high traffic ones. And then we have two single ways through the edge bending to the drilling, and then one backwards for going to the assembly. And as you can see here as well, this kind of intermediate stock is directly on the floor, utilizes a little bit more space, of course, but therefore we can go with this yeah, space saving and more cheaper underwriting AGVs. So there's always stacks on a tray, and then we can access everything. And also, as well, in a more narrow shape building, from the sawing, edge bending, CNC drilling inside the intermediate stock, and then afterwards we get the assembly part here with two long parallel ways in one direction each. Yeah, but when we are talking about the building, which conditions are necessary? So on the one hand, of course, we need undamaged floor. If you have bigger cracks in your floor, you need to repair it at first, because all the sensoric of or most of the sensoric of the AGVs are looking down and checking. And if there are cracks that might irritate, and as well, the wheels need to have a very plain floor. Also, the slopes, if you have level differences, the slopes should be not that better long and low, but not short and high. Expansion joints, if you have there any big ones, it should be built out as a press joint, and clean and dust free. And that is, of course, a funny topic, because we are producing dust all the time, right, in our industry. And therefore, you need to make sure that you have at least a dust extraction. I saw also customers who were operating completely without a dust extraction. It was completely a mess. So dust extraction is a must, and also a proper dimensioned one. So if I have only a small one but a big machine, then it doesn't make sense. And yeah, then in addition, even with a perfect dust extraction, you need to clean the sensors once a shift, but that's a very easy and fast, a quick thing which is done just with a kind of or with your hands or something, just go over it and put a little bit of dust down, and then it will work for the next shift properly. And then I also mentioned the doors and gates. The control system, of course, needs to talk to the doors and the gates. If the AGV is crossing or entering some doors. And therefore, it needs to be make sure that the opening signal should come early enough, so the AGV is not waiting for a door. That wouldn't make sense, because transports valuable goods for processing, and the door should be open before the AGV will arrive. Yeah. And yeah, now I would like to introduce some application possibilities and my point of view about that. So of course we have the warehousing and also the goods receiving area. And what I have to say right now, it is not possible to unload trucks by an AGV. That will come in the future, but right now it's not possible to unload it. But afterwards, we can, for example, simply with a worker and a normal forklifter, we can unload the truck, and afterwards the worker can continue some other work. But the AGVs will take care of distributing it quite well to the warehouse, to the raw material warehouse, and so on. And there, the big advantage of AGVs, from my point of view, starts. So we have now the goods receiving department, and we have the raw material storage. So two departments, and we can now easily interlink those departments by using an AGV. That's, I think, the most advantage of them, to don't have several departments with their own process, but now we can interlink it. And for example, we can do that on the one hand for let's say raw material with the panels, sheet panels, and we have all our B and C material inside our panel storage, but our A material for a second saw which stands outside or has an outside exit entrance, we can then buy an AGV, we have then a complete automatic warehouse, right? So we can our A material bring to the saw for the A material, and B and C is fed by the horizontal panel storage. So, but then we have a complete panel storage, completely automatic. Otherwise, example is picking, of course, because on the left side you can see that's an example out of the furniture industry in Germany. Nolte Kitchen it is, and it's a very big kitchen manufacturer in Germany, and he uses those AGVs and one person for picking, and this AGV is following the operator, and he goes in several aisles, picks the according frontals out, put it in those trolleys you can see here in blue, and afterwards this AGV brings the proper sequenced trolley directly to the assembly line. So there we have again this interlinking of different departments, the intermediate stocker and the assembly line, and that's quite perfect. Of course, with a short buffer in between for safety reasons, but from a principle, we have this flow from A to B directly and automatic. On the right side, we can see how, for example, Amazon is doing it in their fulfillment centers. And that is also a part I really like, because here we have realized the goods to man system, and that's quite important. We have here the AGV, which brings this racks to the picking cell, and the operator here is then picking out the certain products, and then the AGV is bringing this rack back, and the next one is coming. And that's quite nice, because now they can productively work all the time. They don't need to walk, right? Another one is of course, in general, the transport and the distribution of hardware, for example, from the warehouse to the assembly line, or edge material from the warehouse to the edge bending line. So no worker needs to go and fetch it and walk all the time, and in the meanwhile find some other colleague and talk to them or whatever. Even the distances are quite long mostly, so that would save time as well, and the operator can be more productive. And then, of course, the interlinking of this single machines, it's for homemake, for example, that's right now in their focus. So there we can see where we interlink different machines inside the production. But yeah, with those slides, I also want to say that we are not only focused with inside the production itself. We need to look at the entire building where we can use it. So also in assembly area, that's in Germany, a chair manufacturer who is using this AGV for assembling, because they have several similar products, but with slightly differences. And therefore, for example, this chair might go then and skip this station because there's something added this product doesn't need. And then they can skip and go directly to the next station. Then we are not talking directly about a straight assembly line, more about a flexible assembly line or assembly area more, because then it can go through completely individual according to the customer order. And of course, in the end, we need to ship the parts. And right now, if we have more or less standardized pallets, that's quite easy right now even to load the trucks. It's not possible to unload it because we don't know what we get, but we can create a full truck by some certain software, and then the AGV gets the information where exactly to position the pallets. And yeah, so that was more or less it. So now I would like to summarize. Benefits, on the one hand, we have the flexibility because we are completely flexible. If one machine breaks down, let's say we have two edge bending lines or edge benders, we coming from the saw and edge bender one is broken down. So the system then of course knows that, and we can easily reroute the material to edge bender 2, and that would not so easy if we do it like with a roller conveyor or something, because we can't change the direction of the roller conveyor, right? Scalability, if we, in our example, we have those two edge bending lines and one saw, and now we buy a second saw. It's done in 5 minutes to adapt those routing to the system, and 5 minutes later, to build up the saw will last a couple of days at least, and 5 minutes later we can then go to this new created saws and let it go to the several things. Transparency, of course, it comes together with the system, because then we exactly know where the vehicle is located and what kind of parts are on. So we eliminate searching times for several parts because we exactly know where is what. And the space effectiveness, because if we have, for example, an unfavorable shape of the building, for example, several small buildings and there are some kind of connections in between, we can't guarantee a nice flow by using roller conveyors, for example, because we need to cross them in somehow. But with an AGV, the way is always free to cross, only when I go there with an AGV. So that's quite nice to reach at, even the hidden corner in the very last building. It's quite easy to reach those. Of course, we have then the automation benefit as well, and innovation as well, because it's over 60 years that they are existing, but especially in our industry and with this modern sensors and so on, and technology, it's quite innovative to have those, and even for the competitors, it sends signals to say, okay, here I'm innovative and I'm interested in being there in the future as well. On the other hand, the challenges. Right now, as I mentioned, the AGVs are not that familiar to the industry. So the project effort for the first couple of years is, of course, higher compared to an traditional project of planning the production. But more in a detailed planning. On a principal planning, it is more or less the same. There's no difference. But if you then go in a second step in a detailed planning, and all the suppliers are talking to each other and so on, then it gets a little bit higher effort, because not everyone knows exactly about all the interfaces which are used and so on. Yeah, then we have the space efficiency. That's also a point, because if you don't use the forklift AGVs, then we need to place all things on the ground, and that results, of course, in higher space requirements. But on the other hand, an underriding AGV can't go up, but uses less space in the while moving. Right? Yeah, and we mostly need additional part handling, like some kind of gantry or robots to handle those parts. If the part is in a kind of one-piece flow, always on the belt or on the conveyor, it doesn't need additional handling. But I mean, of course, yeah, most of the time you need to interrupt the process for buffering or something. Yeah, and the limited vehicle speed, it comes from, yeah, if you have loads on and you go quite fast, and then there's a worker, you can brake, you can stop the vehicle, but if you are too fast, the loaded good will continue going forward. So that's why, especially with interacting with humans, the speed is a little bit limited and can't reach really high speed. But I mean, the speed right now, it's quite okay. It's yeah, it's 3 to 5 feet per minute. No, per second. Sorry, per second. So yeah, and what to consider, preconditions. What should be there? There's various production routes are possible to. So as I mentioned, with the example with the 2 edge benders, we can reroute directly and intermediately. We have a redundant production then created by having several edge benders, and I always say better you have 3 small edge bending lines compared to 1 big one, because if the 1 big one is breaking down, you can't produce. But if one of the small ones is breaking down, then it's no issue for you. Then you can continue producing and yeah, relaxed, waiting for the spare part. Yeah. Then, as I also mentioned, the interdepartment processes, to interlink them, it's from my point of view, really the biggest advantage. If you don't have this interlinked processes, interdepartment processes, or if you don't want to consider those, it might not that useful to think about AGVs. Also, there's a, yeah, also, as I mentioned, this unfavorable facility shapes. I don't know how it really looks like in the US. I was only once for one project in the US, but if you have very cornered shapes or something, and then it's might be sense to think about an AGV system. And we also at Schuler did some case studies about that, and we realized that is mostly every time it is at least useful to consider one concept with an AGV system as well. I definitely not say that an AGV system solves every problem and you only should go for AGV systems. Definitely not. But most of the time, if the preconditions are there, it might make sense to at least analyze the advantages and the disadvantages in this special case. And then in the end, after the analysis, we will see definitely if it makes sense, if we should choose an AGV system or not. Yeah, and that is mostly the part where I am involved in the projects and where Schuler can support you as well. When you like to have an analysis about your production, we will do that from a very high point of view at first and really ask for your demands, and according to that we will plan together with you and consider different technologies and make analysis, and afterwards we will definitely know what fits perfect for each solution, each case. Yeah, so the very last slide, I would like to give you some kind of out view of the future. So I see in the future the unloading of trucks will be coming quite nearly in several years, I think, a couple of years, because yeah, the 3D palette recognition and also the object recognition is evolving quite fast. So, and that is the missing part to doing it, because loading is still almost possible. And then we will have this semi-automatic planning systems, because right now it's a kind of it's more on the supplier side, but it's kind of a lot of manual planning from the supplier side, and that is where I think also the project effort and the project costs from the AGV supplier side will decrease when this automated planning will come. And yeah, as I mentioned in the beginning, the object recognition and autonomous driving, that are topics also from the car industry, and I really think that in 5 to 10 years, perhaps more, we can really profit from the car industry, because yeah, it's more or less the same, different surroundings, but from technology side of view, it's more or less the same. We have objects we need to recognize, and we need to have this intelligence inside the vehicles to have a decentralized system. And yeah, that's would result then, and upper right picture you can see, like we have this AGV which goes around pallets or objects which are in the way, and that's right now not possible, but in the future it will definitely be. All right, so I think I'm done for right now, and I thank you for your attention. If you now have questions, yeah.
Hey, thank you, Eike. We appreciate that. Again, just to remind our attendees that are with us, if you have any questions regarding automated guided vehicle systems or anything related to Schuler Consulting, you can post it now in the Q&A window. And while we give you a couple seconds there, Eike, I just have one question for you. If we're talking about a typical facility, and let's say we have 10 vehicles working in that facility, do you as a consulting team recommend 10 charging stations? Is that ratio 1-to-1, or do we do one charging station for every 3 or 4 vehicles? Can you provide a little bit more information there?
Yeah, sure. Thanks for this question. That's not a ratio of 1 by 1. Mostly it is, you can't really say how the ratio is. It also depends on how long the distances are, but it's definitely less charging stations than vehicles. So mostly, for example, one customer in Germany, there are 3 vehicles and one charging station, one inductive one is enough. But that is not that far distances. And yeah, it also depends. If you want to be on the safe side, add one more charger than necessary. But it's, yeah, since
Okay.
you charge continuously over the day, always when a vehicle is not used, you can avoid so many charges.
Great. Thank you for that. I don't see any more questions in the Q&A window, so I will just remind our attendees that if you do have further questions for Eike or the team at Schuler Consulting, you can contact them using the email you see on your screen there. You can contact Eike at eike.hein@schuler-consulting.com. Again, that's EIKE